Hi everybody, today I welcome you all for the practical session on demonstration of Mooney viscosity and stress relaxation of natural rubber. So here you can see the Mooney viscometer available in the rubber technology laboratory, and using this viscometer uh, basically we are going to determine the Mooney viscosity and stress relaxation properties of natural rubber. I am Ishara Vijayasinghe, lecturer in rubber processing technology, and Mr. Chatura Gunaratna will support me to conduct this practical session. Okay, let's start our journey. So before going to the practical and to take the hands-on experience on determining Mooney viscosity and stress relaxation of natural rubber samples, so I think discussing some aspects or theories regarding this Mooney viscosity and stress relaxation is more worth. So Mooney, the term Mooney stands for the name of the founder of this viscometer. So he is the Mooney. So he found this Mooney viscometer, and as a respect for him, the viscosity of natural rubber is measured in Mooney units. Here you can see the Mooney viscometer available in our laboratory, that is Mooney MV2000 series. The manufacturer is Alpha Technologies. So from this Mooney viscometer we can obtain this type of graph. So in the y-axis of this graph it gives the Mooney viscosity in Mooney units, and x-axis shows the time values, means the testing time. So from this graph and from this region of this graph we can determine the viscosity of our rubber sample. Then from this part of this curve we can take the stress relaxation properties, means the uncured rubber elasticity. So then Mooney viscometer can be used to measure the viscosity properties, viscous properties of the natural rubber, as well as the elastic properties of uncured rubber. Okay, we will see what are the factors affect the Mooney viscosity of natural rubber. Actually, molecular weight distribution of natural rubber, and molecular structure of natural rubber, stereochemistry, and chain branching, then non-rubber constituents, proteins, lipids, carbohydrate, metal ions, etc., and finally the impurities of natural rubber. Those can affect the Mooney viscosity. Then we'll see what are the factors affect the stress relaxation properties, means the elastic response of natural rubber. So those are molecular weight distribution, molecular structure, chain branching, gel content like factors. Okay, now we know what is the Mooney viscometer and what is the result that can be obtained from this Mooney viscometer. Okay, before moving to the theories of the Mooney viscosity and stress relaxation, so we will see what are the main parts of the Mooney viscometer that are important to measure the Mooney viscosity and stress relaxation properties of natural rubber sample. So you can see here rotor cavity and dies. So this is the rotor which is used to measure the Mooney viscosity of rubber, right? So there are two types of rotors, small rotor and large rotor. Based on the requirement, we can choose which rotor has to be used in determination of Mooney viscosity, right? For your information, the hardness of this rotor is 60 HRC. So these are the specifications of small rotor and large rotor. So the large rotor, the diameter is 38.1 plus or minus 0.03 millimeters. In the small rotor, the diameter is 30.48 plus or minus 0.03 millimeters. The thickness of rotors is 5.54 plus or minus 0.03 millimeters. Okay, here you can see the upper die. So it is mobile die, right? So we can open the cavity by taking this upper die up, and here is the lower die. So it is stationary, it is not movable. Here it makes a cavity, right? So the volume of this cavity is 25 plus or minus 3 cubic centimeters. This rotor rotates inside the cavity. So we need to measure the Mooney viscosity of rubber. So then we need to load our rubber sample to this cavity. By taking up this upper die, we can put our rubber sample here, then close this upper die, then rotate the rotor at a given condition, then we will get the Mooney viscosity and stress relaxation curves. Okay, so we have to fill our rubber sample to this cavity, and the rotor will rotate at 2 rpm rotational speed. That is a constant speed, means the rotor always try to keep its rotational speed at 2 rpm revolutions per minute, and the rotational rate at 0.21 radians per second. This condition is used to measure the Mooney viscosity and stress relaxation of rubber sample loaded into this cavity. So that is the basic principle behind the Mooney viscometer. We load our rubber sample to the cavity, then close the upper die, then we will give some kind of temperature, maybe 100 Celsius, right? Then we will start the Mooney viscometer, means the rotor will start to rotate at 2 rpm, right? Then it tries to keep 2 rpm always throughout the test. Then it will measure the Mooney viscosity and stress relaxation of rubber sample. After we measuring the Mooney viscosity first, then we can measure the stress relaxation properties of the same rubber sample. To do that, at the end of the Mooney viscosity test, we need to stop the rotation of this rotor suddenly, right? Then we can measure the stress relaxation properties. You can see the typical Mooney viscosity and stress relaxation curve here. The y-axis of this curve gives the viscosity of the rubber in Mooney units. Actually speaking, the Mooney viscosity is measured in arbitrary values, means those values don't have an SI unit, but however we use these values and we measure these values in Mooney units. Actually the Mooney units is not an SI unit. The x-axis gives the time, it is measured in minutes. So you can see the shape of this Mooney viscosity curve. Here is the Mooney viscosity curve, and this is for the stress relaxation curve. We can perform these two tests together using our Mooney viscometer. In principle, the Mooney viscosity directly proportionate to the molecular weight of rubber. If the molecular weight is high, the Mooney viscosity is high. If the molecular weight of rubber is low, then the Mooney viscosity of that rubber is also low. So that is the principle has to be kept in your mind to interpret these results. Measuring of Mooney viscosity of rubber will start at the first minute. Means we give 1 minute time for our rubber sample to get heated. Means we put our rubber sample to the cavity which is heated up to 100 Celsius. From where this 100 Celsius come, according to the standard, we perform the Mooney viscosity determination at 100 Celsius. So we have to heat our cavity to 100 Celsius temperature, and we need to put our rubber sample to the cavity, then close the cavity. Then we allow our rubber sample, or we permit our rubber sample to get heated up to 100 Celsius. So 1 minute time is more enough to get the rubber sample heated up to 100 Celsius. So that's why we give this 1 minute time. That is technically called preheating time. Then what is testing time? So at the first minute, our sample has heated up to 100 Celsius during this preheating time. Now the rotor will start to rotate at 2 rpm constant rotational speed. So at the beginning, our rubber sample has high molecular weight, means it should give high Mooney viscosity. That's why initially we can see a large viscosity number here, around 140 Mooney units. Because the molecular weight of rubber is high, then it will give high viscosity value. Means the rotor will need more torque to keep its rotational speed at 2 rpm inside the cavity, right? So what will happen once the rotor will rotate inside the cavity while shearing our heated rubber sample? Due to the rotation of this rotor, our rubber sample will sheared, abraded. Due to that, the molecular weight of our rubber sample will reduce. Molecular weight of our rubber sample will reduce. Therefore, the Mooney viscosity should be reduced. That's why during this testing time period, we experience a reduction of Mooney viscosity. But at the end, it will come to an almost constant value. At the 5th minute, we will stop the Mooney viscosity test, and this constant value is taken as the Mooney viscosity of our rubber sample. Okay, this point is called the initial torque, so it relates to the stiffness of our rubber sample, initial molecular weight of our rubber sample. At the 5th minute, the rotor will stop suddenly. Then the decaying of the torque will be recorded. Then the test will further run for another 2 to 3 minutes, and at that time duration the viscosity values will be measured. So then it will give this graph, that is the stress relaxation curve of the uncured rubber material. Okay, here you saw that the viscosity, the Mooney viscosity of this example is 90 Mooney units. So how do we express this Mooney viscosity? So there's a notation, right? So here is the notation: 90 U ml 1 plus 400 Celsius. We need to give the instrument and its model. So what are the things behind this notation? 90 means the viscosity number, the achieved viscosity of our rubber sample. Then U indicates unmasked specimen, right? M indicates what? M for Mooney. L indicates the large rotor. If we have used a small rotor, we have to use capital S there. Then this 1 is for the preheating time, that is the time in minutes that the specimen was permitted to warm in the machine before starting the motor. And this 4 indicates the testing time, that is the time in minutes after starting the motor at which the reading is taken, 4 minutes time. So 100 Celsius is the testing temperature. So if you have used, we can use our rubber samples, unmasked rubber samples, compound rubber samples, or mass rubber samples. So if we use compounded rubber samples, we have to replace this U by C, right? And normally we use 2 rpm rotational speed of rotor to measure these properties, but if we change this rotational speed, we need to mention that speed also. But normally we use 2 rpm. Okay, now we got the stress relaxation curve after the Mooney viscosity test. So that curve follows the power law model. The stress relaxation curve follows the power law model. Means M equals K into T to the power A, where the M is for the Mooney units during the stress relaxation test, means torque reduction. T is for relaxation time measured in seconds. K is a constant equal to the torque in Mooney units 1 second after the disc or the rotor is stopped. A is an exponent that determines the rate of stress relaxation. Basically it is the relaxation coefficient or the elastic coefficient. So logarithmic conversion gives a linear regression equation for this power law model. So if we have the Mooney viscosity or the stress relaxation, the torque reduction values and the time values, we can plot this graph. We will achieve this type of graph, and from the slope of this graph we can measure the relaxation coefficient. So if we get high value for A, it means elasticity of our uncured rubber is very less. Means our rubber is more processable. We can mix fillers with our rubber very easily. We can handle our rubber very easily when we are going to produce a tire or whatever the product, right? So that means the processability, right? We can handle our rubber sample very easily. So high A values are preferred due to less elasticity of uncured rubber. Okay, this is how we measure the sample weight. So we know the cavity's volume is 25 cubic centimeters, and normally density of rubber is around 0.9799, like that. So using this equation we can measure what is the mass that we need to take for the test. So if the volume is 25 and the density of rubber or the specific gravity of rubber is 0.97, so we have to take 24 grams of rubber sample for the test. Now we shall see the test procedure of Mooney viscosity and stress relaxation. The test method is ASTMD 164604. Okay, we use Enterprise Online Manager software to insert our samples and to change the test variables. So this is the interface. We can go to materials, then compounds, then we can include our new compounds or the rubber samples. Here give the identifier and a brief description of your sample. Then we have to save it, and this information will automatically be fed into Workbench software, which is used to operate our Mooney Viscometer. So this is the basic interface of the Workbench software. We will discuss each segment later. Before we start the test, we need to calibrate our Mooney viscometer. If not, all the things will be wrong. Normally, the viscometer is calibrated after time its results are suspected of being inaccurate, repairs, before any interlaboratory test programs, before testing disputed specimens frequently enough to ensure the maintenance of proper calibration of the instrument. The calibration for torque can be done automatically using the Workbench software. Okay, you can see now the calibration is progressing and now it is completed. The initial viscosity is 0 now. Okay, today I selected a crepe rubber sample, which is a raw rubber type of natural rubber. As you got to know, the sample can be tested as received, means unmasked sample, or as milled sample. The sample may be masked to expel air, to consolidate particles, or to modify it if necessary. When massing, a minimum work or shear should be done to material during sample preparation to get the best results. When NR samples are mill masked, we have to pass 250 plus or minus 5 grams of the sample between the rollers of the standard laboratory mill. So we have to practice D3182 method. When we practice in this, we have to maintain this temperature. The roll temperature of the mill should be 70 plus or minus 5, and the distance between two rollers means the nip size should be 2.5 plus or minus 0.1 millimeters. So we do not allow the sample to rest between passes or to band on the mill rolls at any time during this massing. So roll the sample and immediately insert it endwise into the mill for another pass. Repeat this procedure until a total 10 passes have been completed. At the end, sheet the sample on the 10th pass. Okay, then how to prepare the test sample? Okay, we have to weigh around 24 to 25 grams of massed rubber sample for the test. So this is how we fix our rubber sample to the rotor. Here it is the large rotor, and after fixing these two rubber samples, we have to place two polyester sheets at the bottom and top of the rubber sample to avoid the stickiness of rubber to the surfaces of the cavity of the Mooney viscometer. You can see the interface of the workbench. The loaded samples are in blue color. We have to check the pressure of the Mooney viscometer before the test. This is the switch panel. We can use it to operate the Mooney viscometer, and we have to place our rubber sample in the cavity safely, and we have to close the cavity then. So after closing the cavity, we allow 1 minute time to preheat the sample to 100 Celsius. In the workbench interface, we can take the test time, then the viscosity value, and the test temperature of the upper and lower platens, and the viscosity curve and relaxation curve, and the temperature curves of the platens, as well as the summary of test results, the progression of the test, and details of the test samples. So those can be directly read from this interface. Now time is passing, and at the first minute the rotor will start to rotate. Then you can see viscosity curve starts to draw. You can see it marked the initial torque, a high value. Now the curve is progressing. Now the viscosity value is getting reduced due to the reduction of molecular weight occurs due to the shearing action of the rotor. Now at the 5th minute, the viscosity test will end and the stress relaxation test is started. Now you can see how the stress relaxation test is progressing. So now the test is completed. We can directly read the test conditions and the basic test results from this interface. But I recommend you to go to the results of the online manager. Then you have to refresh it. Then at the top you can test find your test result. So you can take the curves and log plot of the stress relaxation from these results. And also for further analysis you can download all the data points from this online manager. Once you open it, you will see all the test results of Mooney viscosity test and stress relaxation test and all the data points measured by the Mooney viscometer. So we can use these data to plot graphs and for further analysis. At the end, we have to close the online manager and we have to exit from the workbench. And I hope you will have some time to answer these post lab questions.